No, sir.
Okay. And tomorrow 7 p.m. is the schedule of your first credit quiz. Okay, and you will get 45 minutes, and there will be 5 MCQ questions. Okay, and format is Google form. Okay.
Okay, sir.
Okay, so let's talk about the first lecture of week 2, which is about uh, motion of an object. Okay, and in case of motion of an object, just the part in physics which is called mechanics basically. So in mechanics we will discuss some motion of an object and the cause of the motion, which is basically force and energy. Okay. Okay, and I will upload the last video lecture. I forgot to upload on the last one because it was about vector. So after this class I will upload the link. Okay. Okay, just wait, let's start. Okay, so first topic was position of an object. If we try to describe the motion of an object, first we have to find out the position of an object, then the movement of that object. So say if we say that the object is 10-meter away or 20-meter away or 30-meter away, then we have to introduce a reference point which is called the origin. Okay, so basically say this is the object. If we consider this is the object, so in this case if we try to define the position of that object, we have to introduce a reference point, which is say this is the reference point. Okay, and here the basically the calculation is 0 because we consider this the reference point or origin. Then if we draw a coordinate system like that, this is x. Okay, so we consider this is x coordinate system, and perpendicular to this we consider y coordinate system. Okay, so here first we are going to discuss the one-dimensional motion only. So the object will be in x-axis only, so that's why we are considering the one-dimensional case. So say the position of that object, we consider say the position of that object is 10 meter. Okay, so 10 meter, 5 meter, 6 meter, particular distance basically from origin. So basically if we try to define a position of an object, we have to introduce coordinate system or we have to introduce a reference point. Okay, which is called the origin. Then say this position is 10 meter, and we can introduce a function which is called x, and this function will change with respect to time, because if we consider at t equal to 0 second, this is the position. So initially time is 0, so that's why the position of that object is here. Now if we consider after a certain time t equal to 2 second, t equal to 2 second, or particularly 3-4 second, this is the position. Then we can say this is x2, and at a certain time, say here you can consider if you consider the time is t equal to say 5 second, t equal to 5 second, then it will be x5. Okay, so now from this we can say that the position of an object is a function of t. So then we can write down a particular function xt, x3, and we consider a certain equation like that. This is, so it's 3t square minus 2t plus 1. Just we consider a equation or particular function. This equation is describing the motion or position of an object basically. Okay, so basically this equation will be given in quotient. Okay, so 3t square minus 2t plus 1 is describe the equation of the position of an object. Now from this, say question is given like that, just find the position find position, new position at t equal to say 3 seconds. Okay, 3 seconds. Then if we put the value of t here, then we can easily find out the positions. And x3 will be this 3 into 3 square minus 2 into 3 plus 1. Okay, from this 27 minus 6, which is 21, so 22 meters. So 22 meter is the position object of that object at t equal to 3 seconds. So the unit of the position is meter. Okay, and we can easily find out the position of an object at any time if we put the value of t on that equation. Okay, so this is the procedure to find out the position of an object. And the basic thing is that if we try to find out the position, we have to introduce the coordinate system. Okay, say at if we consider at t equal to 0 seconds, so if we put the t equal to 0, then it will be 1 meter. So at a certain, initially the object is in 1 meter away from the origin. Okay, so this is the first question. Now second, displacement. Okay, so second topic is displacement. And here we are using one-dimensional coordinate system. Okay, so if we consider two-dimensional, then the position will be at a certain point like that. So here, or particularly here. So in that case, we have to write down the position function as xt and also yt, because the equation is two-dimensional. So that's why it will be mainly changing with respect to at the direction of x and also at the direction of y. Okay, so here we were discussing one-dimensional case only. Okay, so displacement I will discuss two-dimensional case in second mainly next discussion class. Okay, so displacement is basically change in position. Okay, change in position. Now someone tell me, what is the difference between displacement and distance? Difference between
displacement requires direction.
Yeah, and distance.
Distance does not need any direction.
Okay, so basically displacement is a vector quantity and distance is a scalar quantity. Okay, so say the object, certain object is moving rightward, then downward, and again leftward, then upward. So in that case, the final position and initial position of that object is same. So that's why the displacement at that case is 0. But distance, in case of distance, we have to we have to calculate the total path. So this plus this, and this plus this. Okay, so it will be the distance. Okay, so in case of displacement is a vector quantity, and which is called the change in position, which is basically del x. Okay, so another thing is that here this part is magnitude only. So if you try to write down this as a vector, then you can introduce a unit vector I here, I cap, because this is one-dimensional. So in one-dimensional case, so if the equation is given in y only, so yt, then the unit vector will be z. If the j, if you consider this is z direction, this equation is given in along z equation, then you can write down k. Okay, so basically here using the one-dimensional, that's why I'm not using the unit vectors. So you can use unit vectors, or you can just use the magnitude only, because the magnitude and the vector will be same. Just only difference is you have to just write down only a unit vector here. Okay, so displacement is del x. It's also a vector quantity, and this displacement direction is x along the x-axis. So that's why no need to write down the I cap. Okay, so del x is equal to change in position, which is final position minus initial position. And here this final position is basically the position at time tf, and this is the position at time ti. Okay. Okay, so now if the question is given like that, question number B, find the displacement del x equal to what between t equal to 3 second to t equal to 5 second. Okay, t equal to 3 second to t equal to 5 second. Okay. Okay, so in this case we have to find out the position first. So x3 is 22 and x5. So if we put the value of t equal to 5 at that equation, this is 5 square is 25 into 375 minus 10, which is 65, so 66 meter. Okay, 66 meter is x5. Now if we put the value here, then we can say del x is equal to final position is x5 minus initial position is x3. So this is equal to 66 minus 22, which is equal to 44. So 44 meter, and the unit of the displacement is meter. So 44 meter is the displacement between time t equal to 3 second to t equal to 5 second. It can be minus also. Okay, because displacement, say if you consider the object position is along the negative x-axis, then it may be a minus. Okay, so sign is not important here. If you just sorry, sign is also important here, but if the object is in negative x-axis, so it will be negative. Okay. Okay, so this is the displacement. Now next part is velocity. So velocity, so we can define velocity as the change in position with respect to time. So velocity is basically change in position, change in position divided by time interval. Okay, change in position divided by time interval. And here the change in position is basically displacement del x, and time interval is del t. So here you can use I cap, because in one dimensional case is I cap. So if you go to two dimensional, that there will be extra term is del y by del t j cap. Okay, so I will discuss this part in next lecture, so that's why I'm not going to this part. First is velocity del x by del t, basically change in position divided by time interval. Now velocity, here velocity is two types. First is average velocity, and another is instantaneous velocity. So what is the difference between average and instantaneous velocity? Anyone tell me what is the difference between average and instantaneous velocity? Or what is the meaning basically average and instantaneous? Okay, so average is basically the velocity throughout the motion, total motion, or at a certain time interval. And instantaneous velocity is basically velocity considered as at a certain time. Okay, at a particular single time. Okay, or instantly, the velocity or instant velocity of an object. Okay, so in case of average velocity, there will be a time interval, so del t will be very large, say 435 second, particular time interval, there will be a particular time interval. But in case of instantaneous velocity, we consider del t tends to 0, so there is no difference uh, time interval. Basically, there is no time interval in case of instantaneous velocity, and there will be a single time only, say at t equal to 10 second, t equal to 5 second. Okay, so this is the basic difference between average and instantaneous velocity. Okay, and the formula to calculate the average velocity and instantaneous velocity is, so this del x by del t is called the average velocity. And if we take the limit like that, say we consider same velocity, just only difference is here, there is a limit where del t tends to 0. Okay, so at that case del x by del t. Now I think you are familiar with this type of limit, because in mathematics there is a formula like that. If there is a limit del t tends to 0, then we can write down this part as a differentiation, so dx by dt. So dx by dt, so basically first order differentiation of position gives the instantaneous velocity of an object. Okay, so first we have to introduce differentiate this del x, then we have to put the value of t. And in case of average velocity, no need to differentiate, just find out the position at a certain time. Okay, then we have to just divide the change in position with time interval. Okay, so this is the procedure to calculate the velocity. Now let's solve a problem related to this topic. So equation, this equation describes the motion of an object. Then in equation, just the question is find the average velocity, or equation just in this question is just find the velocity between time interval t equal to 3 second to t equal to 5 second. Okay, equal to 5 second. And another question is find out the velocity at t equal to 10 second. Okay, t equal to 10 seconds. So here the difference is here is a time interval, or there is a large time interval, basically 2 seconds, and there is 2 time given in case of average velocity, and in case of instantaneous velocity there is a single time given instantly, basically at t equal to 10 seconds. Okay, so any question?
No, sir.
Okay, so first case, if we try to find out the average velocity, then we have to write down like that: x5 minus x3 divided by 5 minus 3, because this is the time interval. And here this is basically displacement between 5 second to 3 second, which was 44, and divided by 2, this is equal to 22, and the unit of the velocity is meter per second. Okay, can you please mute your microphone, Tanjim? Yes, okay, thank you. So this is the average velocity. Then in case of instantaneous velocity, so v is equal to dx by dt, so we have to differentiate this. So in this case you have to memorize a formula, which is d dx of x to the power n is equal to n x to the power n minus 1. Okay, so this is the formula for differentiation. And differentiation of constant is equal to 0, or if there is a constant here, so c, then just it will remain same c. Okay, now here first x is given 3t square minus 2t plus 1. Our differentiation of t square, so 3 remains same, 3 into 2t, because 2 minus 1 is 1, so that's why power is 1, minus 2 into 1, this is t to the power 0 is 1, and the differentiation of 1 is 0. Then it is equal to 6t minus 2. Now if we put the value of 10 here, then b10 equal to 6 into 10 minus 2, this is equal to 58. Okay, so the answer is 58 meter per second. So this is instantaneous velocity, v10 equal to 58, and average velocity is 22 meter per second. Okay, okay, so these are the mainly procedure to find out the velocity, either average velocity or instantaneous velocity. And next question is next topic is acceleration. Okay, acceleration. Okay, so acceleration is also similar to the velocity. Acceleration is two types, and the definition is basically change in velocity with respect to time interval. So in case of average velocity, just displacement divided by time interval. So in this case, basically acceleration is del v by del t. Okay, so here the difference is basically the change in velocity, and here change in displacement. Okay, now in case of acceleration is also two types. One is average acceleration, and another is instantaneous acceleration. Okay, so instantaneous acceleration is basically second order differentiation of position d square x by dt square, or we can say first order differentiation of velocity by dt. And average acceleration is basically change in velocity with respect to time. Okay, with respect to time. And in this case v final minus v initial, and here t final minus t initial. Now this velocity vf and vi both are the instantaneous velocity, because this is the velocity at final time and this is the velocity at initial time, basically at a single time. So that's why vf and vi is considered as instantaneous velocity. So in case of acceleration, if we try to find out the acceleration, either average or instantaneous, so we have to use differentiation. So in case of average, we have to differentiate x one times, and in case of instantaneous acceleration, we have to differentiate position two times. Okay, okay, now if the question is given like that, find the average acceleration between time interval t equal to 2 seconds to t equal to 4 seconds. Okay, so there is a time interval, so that's why this is considered average acceleration. And a equal to what? At t equal to say 10 seconds. Okay, okay, now for first case we have to find out the v2 and v4. So v was 60 minus 2. Now here v2 is equal to 10 and v4 is equal to 22. Okay, Now average acceleration is equal to v4 minus v2 divided by 4 minus 2, and which is equal to 22 minus 10 divided by 2, and you can write down here 6 meter per second square. So the unit of the acceleration is meter per second square in SI unit. You can use also centimeter per second square. So here, if the equation if the unit is given centimeter, then you can use centimeter per second square. Okay, but SI unit is meter per second square. Okay. Okay, so in case of instantaneous acceleration, A equal to dv by dt. So first order differential of velocity, so 60 minus 2, which is 6 meter per second square. Now the thing is that after differentiating the velocity, the result is a basically number. There is no variable t. So how can we put t equal to 10 seconds? So if the answer is constant in case of instantaneous acceleration, so then we can say the acceleration is constant throughout the motion. Okay, so it's constant at t equal to 1 second, 2 second, 3 second, 100 second, or 12 second, or 10 second. Okay, so that's why the average acceleration is 6 and instantaneous acceleration is also 6. Okay, so this is the mainly procedure. If there is a variable here t, then we can put the value of t. So here acceleration at t equal to 10 second is 6 meter per second square, and also acceleration at 2 second, 4 second, or 100 second is also 6 meter per second square. Okay, so these are the procedure to calculate the position, displacement, velocity, and acceleration in one dimensional case. Okay, and another thing is that if a equation is given like that, a equal to 3t minus 2, then from that equation, how can we find out the velocity and also position? Okay, so any idea? Do you have any idea about this? How can we find out the velocity and position if the acceleration is given as a function of t? Okay, so if we reverse the process differentiation, so reverse of differentiation is what?
Integration, sir.
Yes, so we have to integrate. So if we try to find out the velocity, then we have to integrate the acceleration with respect to t, and if we try to find out the position, so we have to integrate the velocity. Okay, so this is the process for reverse process. Basically, if acceleration is given, we can calculate the velocity and acceleration by this process, and if the velocity position is given as a function of t, then we can easily find out the velocity and acceleration by differentiating the position. First time is velocity and second time is acceleration. Okay, so these are the procedure for calculating the acceleration, velocity, and position, and also displacement. And these are the topics covered in first lecture of week 1. Oh, sorry, week 2. Now, do you have any question regarding this lecture?
Sir, I have one.
Yes, okay.
Sir, let's say a car is traveling at constant velocity. Does
Yes.
that mean the acceleration is constant because the acceleration is 0 all throughout the journey?
Okay. So if velocity is constant,
Yes.
then we can say if velocity is constant, then we can say acceleration is 0 if we differentiate the constant. So instantaneous acceleration is 0. Okay.
Yes, sir.
And another thing is that if initially there is acceleration, then we can say mainly there is an acceleration, but mainly throughout the motion, acceleration is 0 considered.
Oh, okay, sir. Thanks.
Okay. Okay. So we can end our session if there is no question. Okay. So thank you so much.
Sir,